Welcome back to the advanced Arduino basic project, and today we will learning about digital voltmeter with 7 segment display. And here is the agenda: overview, components, principle, schematic, procedure of digital voltmeter with 7 segment display. So in this lesson we will program the Arduino to achieve the automation of a digital voltmeter system. The system will automatically measure an incoming analog voltage from a source, then process the data into a readable format, then display the precise value in real time using multiplexed 3-digit 7-segment display. So for this project, what are the required components? That is Arduino Uno, 7-segment display, power supply, resistor, potentiometer and jumper wires. So the circuit follows 3-step process. One is sense, process, then multiplex. During sense, here the Arduino reads the voltage at the analog pin. Since the Arduino's ADC has a 8-bit resolution, it converts 0 to 5 volt signal to a digital value between 0 and 1023. So ADC means analog to digital converter. Then it will process. So here the scaling process will happen. The code uses the formula Vin divided by 2.046 to convert the 0 to 1023 value into a voltage number. So 1023 divided by 204.6 is 5. So this scaling factor is designed to show a value representing 0 to 5 volts. And next process is the multiplexing. So since there aren't enough pins to control every segment of all 3 displays at once, the code uses multiplexing. So it turns on one digit at a time. So here we have 3 display, right? Display 1, display 2, display 3. So it turns on only one at a time. That is very quickly. So it happens so fast. Means every 5 milliseconds. So human eye perceives all 3 digits as being on simultaneously. And this is the schematic diagram, and next is the procedure. First step is build the circuit. So here we having 3 7-segment display and 1 power supply pot, then resistor. So when you vary the pot, you can observe changing the values. And next is the procedure. So step 2 in procedure, step 2 is program. So here you can see int a, int v in. So these are the variable declarations. So we create 2 variables. So here v in holds the voltage we measure, and a, this variable will temporarily hold a single digit we want to show, and input equals to A0. So we tell the Arduino that's the voltage we want to measure is coming in through the analog pin. And here we having display 1, display 2 and display 3. So we define pins 1, 2 and 3 as the power switches for each of the 3 digits on our display, and here we define the segment pins. So we map pins 5 through 12 to the specific physical segments of the display, including the dp also. dp means decimal point. And next step is the setup function. So this runs once to wake up the pins. So here we having pin mode of display 1, display 2, display 3 output. So we set all the displays as a output, and also we set the segment pins as output. So this means Arduino will send electricity out to them to light them up. And here we having pin mode input comma input. We set the analog pin as an input because it is listening for an external voltage signal. And next is the loop function. So this is the heart of the program that repeats forever. So here we having Vin equals to analog read of input. The Arduino looks at pin A0 and gets a number between 0 and 1023. And here you see Vin equals to Vin divided by 2.046. We do the math here. So what you will do means 1023 divided by 204.6 is 5. So this math scales the raw number onto a value representing 0 to 500, means which we interpret as 0 to 5 volt. And A equals to V in percent 10. So we use the modulo math trick to grab the very last digit. So if A is less than or equals to 5, then it defines A equals to 0, else A equals to 5. So here you can see digital write of display 1 low, display 2 low and display 3 high. So because we can't show all digits at once, we show them one by one very quickly. So we turn on third screen here. So that's why display 3 is high. So display of A, we call our translator function to draw the number stored in A. And here we pause for 5 milliseconds, just long enough for the human eye to see it. So this is the delay. Then here we discard the last digit and move to the next one, the tens place. And A equals to, here also modulo math trick. Then we will do the same process again and again. So here you can see we turn off the previous screen and turn on the middle one to the repeat the process. And here first one is high, rest is low. And here you can see in display of int A and switch function. So this function receives a single number 0 to 9. So in case 0, here see seg A, seg B, all are low except this seg G, right? So it gives one number. So which number it will give? So here you can see, so this is A, B, C, D, E, F and this center one is G. So here we consider G as high, rest all low, means all this turn on except this. So this represents which number? 0, isn't it? So this creates the shape of a 0 on the glass. In case 0 shows 0. In case 1, so here you can see the two segments B and C are low except all are high. So this and this are turn on, that is 1, isn't it? So similarly case 2 showing 2, case 3 3, 4, 5, 6, 7, 8, 9. That's all about the code. Let's do the circuit using Tinkercad simulator. So what are the required components? One is Arduino Uno, pot and resistor. Then we need 7 segment display. So search it here, 7 segment display. So here we need anode, then we need 3 7 segment display and 1 power supply is required. So I am taking this. So here I am setting 30 voltage and 5 amps current. So we need to do the connections now. So first I'll do this connection. So here we having A. We need to connect this A to the Arduino pin. So I am connecting this to pin number 4. Then we need to short this A with this. So I am connecting this to pin number A. Similarly, we need to short this also. See here we having A. Yeah. Next is B. So here I am choosing different color for B, and here I am connecting this to pin number 5. So I am connecting this to pin number 6, and this one I am connecting to pin number 5. And here, why I connected this to pin number 6? Because in code I mentioned 6. So we can connect according to the code. Yeah, move this little near, make it straight, then connect pin number B. So here we having B. Make it straight. Now similarly we need to connect C. So here is C, right? So here I am connecting this to pin number 7, and I am changing this to orange color. Next we need to short this pin. Similarly, so here we having C, right, and make it straight, little up and make it straight. Yeah. Similarly we need to connect this also. C. Yeah, C is done. Now we need to connect D. So I am connecting D from this. We need to connect D to the pin number 8. So here I am connecting to pin number 8. Then we need to short. So here I am choosing different colors. So this is D, and this one yeah, D connection is done. Now we need to connect pin number E. So this is DP, this is pin number E. So here I am connecting this to pin number 9, and here I am changing this color to blue. This is E, right? So here we having, right? Yeah. Make it straight, and this one we need to short it. E connection done. Now we need to do the connection of F. So here we having F. We need to connect this to pin number. So I am connecting this to pin number 10. Then we need to short this. So here I am connecting this to F. After this we need to connect, before that, yeah, now done. After this we need to connect the pin G. So here I am taking this, I am connecting this to pin number 11. So here is the 11. Little I move down. I'm changing this to pink color. Yeah, now we need to short this. So now this one should be connected to this G, then this one should be connected to this G. Yeah, this part is done. Now DP is there, right? We need to connect this DP to pin number, digital pin. So here I am connecting this to pin number 12. I am changing it to brown. Then this one to short, then even this we need to connect to DP. Yeah, now this connection is not over. We need to connect this to 1. I'll reconnect. So here I'm changing this to black color. It's easy to recognize, right? And this is pin number 2. Then this one is pin number 3. So yeah, here move a little down. Yeah, I'm changing this color to red. Now this connection is over. Let's connect power supply. So here positive end, I am connecting this positive end to resistor. So this, then we need to connect this to analog pin. So here I am connecting this to pin number A0 and 100 kilo ohm resistor we need. Then I'll connect this to pot pin. So here you can see the pot. Next, this I am connecting to ground. So here let's change the color. Then this pin, yeah, this is the ground connection. Connection part is over. Now we need to write the code. So here I am pasting this code. Sorry. Start simulation. So when we vary the pot, according to that these value also vary. One thing I forgot, here we need 10 kilo ohm pot, not 250. Yeah, let's vary the pot. See, value also changing, isn't it? bits keep on changing based on the pot value. So that is the output. So digital voltmeter using 7 segment display. The process starts at pin number A0. So internally the Arduino has a tool called ADC, that is analog to digital converter. So you can imagine this like a ruler, that is 1,024 millimeter long. If the input is 0 volt, the ruler reads 0. If the input is 5 volt, the ruler reads 1023. The Arduino listens to the potentiometer and gets a raw number based on where the dial is turned. The raw number is nothing but 0 to 1023. Doesn't mean much to a human. So the code acts as a calculator. So it divides the number by 2.046. Why? Because 1023 divided by 204.6 is 5 volt. By doing this, it converts the raw data into a 3-digit number. For example, if the battery you are measuring is 4.5 volts, the Arduino calculates the number 450. The 7-segment displays can only show 1 digit at a time. The Arduino can't just send 450 to a screen at once. It has to peel the number apart. It grabs 0, it grabs the 5, it grabs the 4. It stores these 3 separate pieces of data in its memory, ready to be drawn on the LED. So this is the most practical part of the hardware design. If you looked at the circuit very closely, you should see that only 1 digit is ever actually on at a time. The Arduino turns on the first display and draws 4. It waits 5 milliseconds, faster than you can blink. It shuts off the first, turns on the second display and draws 5. It shuts off the second, turns on the third display and draws 0. Because this cycle happens hundreds of times every second, your brain cannot see the switching. So this is called persistence of vision. So it tricks your eyes into seeing a steady 450 across all 3 screens, isn't it? So finally, to actually show a number like 5, the Arduino refers to its internal map, means the switch case. In the code we use it switch case, isn't it? So here case 1, case 2, case 3. So it knows that a 5 requires 5 specific light segments to be on. It sends electricity to those 5 pins and the LED glows in the shape of a 5. So that's all about the digital voltmeter.